Hey everybody, I'm back to do the lesson 2 practice problems. Number 1 says select all polynomial expressions that are equivalent to 6x to the fourth plus 4x to the third minus 7x squared plus 5x plus 8. So when terms are being added together, right? Adding doesn't matter what order you add things in. And we do want to remember our power properties. We could never add these all together to make something like that, right? You can only add x to the fourth with another x to the fourth. So let's see. This one, that says 6x to the fifth. There is nothing like that in there, so that's not right. This one says 6x to the fourth plus 4x to the third. This one is exactly the same. Yes, this one. It says all. What about this one? We've got 8. We've got 5x. Oops, 7x squared is supposed to be negative, and that one has it as a positive. And that 4x cubed is positive, and they have it as a negative, so that one doesn't work. Let's look at this one. 8, 5x, negative 7x squared, positive 4x to the third, plus 6x to the fourth. It can be in any order that you want. Typically in math, you're going to see it in either ascending or descending order. So see, this has the highest power working its way down, 4, 3, 2, 1, none. Or, technically that's x to the 0 power, first power, second, third, fourth. It would not be wrong if it was jumbled in a different order, as long as all those terms are there with the correct sign. All right, number 2. Each year, a certain amount of money is deposited in an account which pays an annual interest rate of R, so that at the end of each year, the balance in the account is multiplied by a growth factor of x equals 1 plus R. We talked about this in the recap if you listened. 500 is deposited at the start of the first year. An additional 200 is deposited at the start of the next year, and 600 at the start of the following. So imagine that 500 is going to get multiplied by that, and then it's going to get multiplied by it again, the start of the second year, and then again the third year. Right? Now, not until this at the next year, 200 is added in. So it's not going to get multiplied by that 3 times. It's only going to get multiplied by that 2 times. And then finally, 600 gets multiplied 1 year later. Again, what does X stand for? That interest 1 plus whatever that rate is. We're calling that X. So if I clean this up, this would be 500 X to the third, because I'd be multiplying by that interest rate 3 times, plus 200 times the interest rate 2 times, plus 600 times the interest rate once. What is the amount to the nearest cent in the account at the end of 3 years if the interest is 2%? So X stands for 1 plus the rate. 2% is 0.02, so that's 1.02. So wherever I see X, that's what I'm going to put. 500 times 1.02 to the third, plus 200 times 1.02 to the second, plus 600 times 1.02. Calculator out. Uh-oh, did it officially die? I gotta back up. Here we go. 500 times 1.02 to the third, plus 200 times 1.02 to the second, plus 600, is that right? Times 1.02, just 1. I mean, you could put to the first power. So this is money, $1,350.68. All right, number 3, consider the polynomial function p given by p of x equals 5x to the third plus 8x squared minus 3x plus 1. Evaluate the function at x equals negative 2. I'm just going to put negative 2 wherever I see x. That's to the third squared Now, you do want to be really careful on calculators when it's a negative number being raised to a power. You want to put parentheses around it. I'm just going to type, I could do this in my head too, right? This is 5 times, what's negative 2 times negative 2 times negative 2? Negative 8 plus 8 times, what's negative 2 times negative 2? Positive 4. Negative 3 times a negative 2 makes 6 plus 1. You could totally do this on a calculator too. Miss Austin's just trying to show you don't have to. That'd be what? Negative, or here, we'll do all positive. So it's 38, 39. So negative 1. Hopefully that's right. Let's try it on here. 5 times negative 2 to the third plus 8 times negative 2 squared minus 3 times negative 2 plus 1, negative 1. All right. I still got a job. All right, moving on. Number 4. And here's that open top box. Remember I told you, you're going to want to understand what this is talking about, right? This is just about the volume of a box created by cutting out the corners of a piece of paper. The only thing that changes in this expression is 2 numbers. If you haven't noticed yet, it's these 2. That's the size of the paper. This is how big you're cutting out. And if the paper is 7 by 5, you're subtracting 2 of those cuts from each dimension. Go back and watch my lesson recap if you need help. All right, an open top box is formed by cutting squares out of a 5 by 7 piece of paper. The volume in cubic inches of this type of open top box is a function of the side length x in inches of the square cutouts and can be given by v of x equals 7 minus 2x times 5 minus 2x times x. Rewrite by expanding. Oh, so now we've talked about why this didn't really look like lesson 2. Let's make it look like lesson 2. Let's actually multiply it. Now, this was something that I left the first Thursday that I was gone as a review of multiplying polynomials. And so if you need help with this, please ask. So remember distributive property. I'm just going to do a quick recap. If you had something like this, you would multiply each of those. But I have 2 things times 2 things. So you can use a box. I'm going to model this with a box. It helps you keep your work organized. I have to do 7 minus 2x times 5 minus 2x. So if you want to think of it this way, 7 has to get multiplied by both of those, and negative 2x has to get multiplied by both of those. So I'm going to use this box to help me. 5 times 7 is 35. 5 times negative 2x is negative 10x. Negative 2x times 7 is negative 14x. Negative 2x times negative 2x is positive 4x squared. All right, now let me clean this up. You see how these 2 on right here, those are both plain x's. I can put those together. And I'm going to put mine in, I'm going to start with the highest power right here. You don't have to. 4x squared, if I put those together, I get negative 24x, and then I get plus 35. Remember, you can only add like terms. They have to have the same power. So now I did this times this. Now I still got to multiply by this. So I have to multiply this whole thing times 1 more x. I don't think I need a box for that. That's just the distributive property, right? So that's going to become 4x to the third minus 24x squared plus 35x. Now do you see that looks more like lesson 2, the investment problem? That's an expanded polynomial. This is called factored form, which we'll learn more about. All right, number 5, a rectangular playground space is to be fenced in using the wall of a daycare building for one side and 200 meters of fencing for the other 3. This is just like number 1 from lesson 1. All right, here's the daycare. And they're going to make a playground. And we're going to call this dimension x, and they are doing 200 meters of fencing. So how much is left for this? 200, take away 2x's, whatever that was. It says, what is the area of the playground when x is 50? You could either, well, first of all, actually, I think it'd make more sense to do this part first. Or maybe you could just do this in your head. If this is 50, right, and this is 50, then that's 200 take away 2 of those, which is 100. So that's what? 200 take away 100, which is 100. And how do you find the area? 50 times 100, so it's 500. What is this in square meters? Oh, I'm not putting Miss Austin. I just realized I did that on one of the other ones. That should say meters square, not square square. It doesn't make any sense. Write an expression. Okay, well now forget these real numbers. Use these expressions to find the area of this depending on how big they make the length and the width. It's going to be x times 200 minus 2x. That's the area. What is a reasonable domain? This is a real life problem. The lowest we're ever going to have is, right, anything bigger than 0, but less than, I've got to have enough for this dimension. 200 take away 2 what's would make it obsolete. I couldn't let this be if this was 100, 100 and 100 would make 200 and there'd be nothing left. So I'm going to put that as my upper limit. I could do 99. It'd be a really long, skinny one, but okay, so anything from 0 to 100 makes sense in this problem. All right, last one. Number 6, Tyler finds an expression for v of x that gives the volume of an open-top box. Okay, here's that problem again. We don't know how big the paper was, but they typed in some expression they came up with. Here it is. We know the max volume's right there, and it goes from 0 all the way to right here. What would be a more appropriate domain? They said to go from -1 to 7. I don't need to go out here to 7. I'm not going to have a negative volume. I only need to look from here to here. So I would say 0 to maybe 3.5. What is an appropriate max? It looks to me, if I was zooming in, I don't know, like 52. I think it's a little over 50. Okay. I hope that helped. I'll be back for a recap on 3 and the lesson 3 practice problems.